Reservoir simulation models are one of the tools used by petroleum engineers to enhance production. The purpose of our project is to perform a history match of the Fordoche field in Point Capee, Louisiana, using the CMG builder model to maximize secondary recovery. This unique field presents the need of additional analysis using history matching due to the high amount of reservoir sands and estimated reserves. It is a pressure-depleted black oil reservoir with about 10 million barrels of estimated reserves in which the operator is looking to tap into through enhanced oil recovery. The change control process of our project is done by a majority vote amongst our group. During team meetings, when a change within our project plans is requested by a member, the idea is evaluated by each member and then put to a vote. Our staffing is organized such that all members have equal responsibility when submitting assignments. Each member of our group has been designated certain responsibilities for our project. Our work breakdown structure contains our project's deliverables along with the work breakdown definitions and baseline. Our baseline demonstrates a fixed schedule of events and shows which tasks have been completed or in progress.
For everyone to gain experience in leading a project, we'll take turns in each position. There are 5 people in our group with 4 different jobs. There will be a project manager, a documenter, secretary, and 2 people assigned specifically to data input and working with the CMG Builder software. The project manager is responsible for making sure we stay on the task during the meetings so we accomplish the task at hand in a timely manner. The leader will provide organization and structure to the meetings by creating and following an agenda. If any unforeseen funding is needed for the project leader will notify the team and will hold a meeting to discuss this. The documenter is responsible for keeping track of what is said and accomplished in each meeting. They're responsible for logging the minutes of each meeting and where the meeting took place or if there was any cost associated with the meeting. The secretary is responsible for setting up meeting locations and reserving them if needed. They will work with the project leader to set a time that works for the group. The data input and CMG operators are responsible for putting existing data into the CMG builder. The people doing this job will put in extra time working with the software compared to those with additional responsibilities. However, everyone will be working on putting the data into the software properly and building the reservoir on the simulator.
For our project, we are doing a history match on the 8750 sand in the Fordoche field, located in Point Capee Parish. The data has been given to us by project sponsor, Professor Veazey, and is from multiple sources. The history match is so we can help predict future production. If unforeseen issues arise, we will potentially have to change our project scope. If this occurs, we will hold a team meeting and discuss the issues with our project sponsor.
Our management plan for the project's costs includes having a cost manager with the duties of tracking and managing costs throughout the duration of this project. This also includes ensuring that our team spending falls within our proposed budget, adjusting the project's cost baseline as needed, and procurement of the necessary approvals in the event additional spending occurs. Since our project doesn't really require much of any active spending, the management of costs primarily consists of updating our expenditure sheet monthly and constantly looking for alternative ways to minimize spending. This expenditure sheet will then be reported to our project manager and project sponsor quarterly during status updates. The cost manager's overall goal is to ensure that we are working within our cost management guidelines. To the right is the general overview of our cost baseline and the costs expected to be incurred throughout the life of the project. Our cost baseline is easy to follow and monitor since the very nature of this entire project primarily consists of working in only one software, CMG. These costs are explained in detail in the project management plan and also describes where they originated from. Here's a chart that displays where we expect to be in comparison to the cost baseline. We plan to cut spending activities throughout the life of our project to a half of the proposed budget. This is also explained in detail in the project management plan. As for our procurement management plan, we don't expect any major procurement activities to occur during this project, as the necessary software need is already in place. However, in the event that any procurement activity must occur, the project manager will work alongside the cost manager to get approval from the project sponsor. If any additional services or software is needed, they will conduct proper research to ensure that they are compatible with the CMG software. All procurement activities are limited to a total of 25% of the entire budget.
The Communications Management Plan outlines our communication procedures, explaining who communicates what and how it should be composed. In addition, it provides everyone with a complete contact list for convenience or in the event of role changes.
We need all team members and collected data for the entirety of our project. Throughout the fall semester, we have collected data and have been learning the software. During Christmas break, we will begin working in the simulation software until we have completed the project as outlined in the resource calendar.
The milestone list consists of 12 project milestones. Most were created before we began. However, as the project has developed, some new milestones have been added.
Our schedule management plan depicts how we created a project schedule through Microsoft Word, coordinating our bi-monthly meetings, due dates, and other project milestones. This schedule is updated once a month by the project manager. If someone feels the changes to the project schedule are needed, the project team will meet and determine whether the change is essential. In the case the project sponsor determines the need for a scope change and it affects the schedule, the project sponsor and team will meet to discuss the necessary steps to complete the project in the same time frame.
The quality management plan is an important part of our project. Our purpose is to describe how quality will be managed throughout the life cycle of the project. For our project, all of us first made sure to develop a solid topic. While we came up with the Fordoche field analysis, we knew we had enough resources, data, and time to make it a successful project. Our quality roles consisted of this. Brett took care of the data, simulation, milestone, schedule management plan, and communication with the advisor. Rashida arranged the cost baseline, procurement management plan, and handling pricing of the project. Jonathan took care of the introduction, approach, and project scope of our field analysis. Austin made sure to have the baseline, introduction, staffing, and changes of the management plan. Finally, I kept up with the minutes, quality management plan, risk register, and quality baseline. The risk management is an important part of our project. In every project, there are quite a few risks involved. The top 3 risks are the following: needing further training with the software expert, the data is not accurate enough, and lastly, the time constraints and cost. The risk register is a listing of all the possible risks associated in our project. While BART has only a few risks, we made sure to ensure we include all of them. The original identified risks are lab software access, project sponsor availability. Additional identified risks are CMG software experts availability, incorrect parameter assumptions, and lastly, mistakes discovered late during model building. The quality baseline for our project is to make sure the quality of the history match we build is an accurate representation of the field's past production. We need to build a model that can accurately predict the past production in order to give an estimate on future production when the secondary recovery project takes place.